Hello, I'm Kayla, and I'll be going over how I figured out that these structures belong to ethyl butyrate. So first, I started off with the IR spectra, and as we know, anything between 4,000 to 200 and 700 will be things that are bonded to hydrogen. Next, we have anything between 2,300 to 2,000 will be a triple bond, and then we have anything between 1,900 to 1,500 will be double bonds, and then anything from 1,500 to 1,000 will be single bonds, and beyond that is the fingerprint region. So first I looked at this peak right here, the first major peak, and I was able to deduce that it is because we do have the carbon bonded to the hydrogen. Now we have this next major peak, and we do know that within the structure there is a carbon that is double bonded to an oxygen, and that is what we see here. So I'll put this double bonded to the oxygen, and then we have another major peak here as well. And from this area, we're able to deduce that it is a single bond, and we know that there are two oxygens. The formula for it is C6H12O2. So we have two oxygens, 12 hydrogens, and 6 carbons. So this one would have to be C bonded to an oxygen. Now I'm going to fill out my IR table. The first frequency would be around 2,950. Sorry for my horrible drawings. And that will be the CH3 functional group. Next we have 1,743, and that would be the carbon that is double bonded to the oxygen. Next we have 1,185, and that will be the carbon that is single bonded to the second oxygen. And then we have another CH2. Then we have a CH3. Now moving on to the carbon-13 spectra, how I filled mine out was that I separated it into two parts. So this area would be sp2, and over here we have sp3. Now right here, I'll label this as 1, 2, 3, 4, and 6. Okay, so now that we have our numbers labeled for each one, we're going to start off with number 1, and I had put the C that is double bonded to the oxygen here because, as we know, sp2 often goes with double bonds. We have that one here. And then for number 2, I had put down the C that is single bonded to the oxygen. And then right here should be CH3, CH2 for 4, CH2 for 5, and then CH3 for 6. And also I have wrote down that anything going towards the left of 100 to 200 would be considered downfield for electronegativity, and anything from 100 to 0 would be more upfield for electronegativity. Okay, now I'm going to fill out my carbon 13 table. So we know we have 6, so 3, 4, 5, and 6. Okay, for the first one, number 1, I have put 173.61, and that would be sp2, which would be the carbon that is bonded to, double bonded to the oxygen. Next we have 60.13, and that would be sp3, and that is the carbon that is bonded to the oxygen. 3 would be 36.32. That will also be sp3, but with CH3. 4 will be 18.57, which would be sp3, CH2. Number 5, 14.32. That will also be sp3, CH2. And lastly, we have 13. And that would be sp3, CH3. Okay, and now that chart is completed. And for the last spectra, we have the hydrogen spectra. So I just went ahead and started to draw what I have written on my paper. And now, as we see, we have A, B, C, D, E. Alright, I also went ahead and already filled out the table. So here we have A through E, and first we have A, which is 4.126, and now have integration of 2H. I figured it was a triplet, triptet, and CH3 bonded with CH2. Then we have B, which is 2.27, 2H, multiplet, CH2, C, 1.665 is 2H, quartet is the C double bonded to the O. Then we have D, which is 1.256, and that's the 3H, and that's a triplet, CH bonded to CH2, bonded to the O. And lastly, we have E, which is 0.96. It'll be a 3H multiplet, CH2, bonded with the CH3. And here down at the bottom, I have drawn out the proposed structure. And here we have this CH3, CH2, another CH2, the carbon double bonded to the oxygen, and then we have an oxygen here, another CH2, and lastly a CH3. I have included the molecular formula right here, which is CH3, CH2, CH2, COO, CH2, CH3. And to figure out the degree of concentration, we have the formula here, which is 2 times carbon minus the hydrogen, minus hydrogen, adding nitrogen, plus 2 divided by 2, and since the structure is C6H2, we have 2 times times 6 minus 12 minus 0 because we do not have any halogens. And we do not have any nitrogens either. Plus 2 divided by 2, and the degree of unsaturation will be 1. Thank you again, and my name is Kayla, and this is group 1. Thank you.